So when I graph those coordinates, I'm going to make this bigger for a minute. I'm going to move him down, make this bigger so I can graph on it. These were my coordinates. My x coordinates were 1, 2. Actually, let me make the pen thicker. 1, 2, 0, 3. And basically, it's going to end up going like this. So my graph goes something like this. And you just basically keep going. Let me squeeze it back down. Move this back up. Okay. Now if I want to eliminate the perimeter, you're going to have a hard time with your equations where x equals t minus 1, y equals t plus 2. Because it's absolute value, you're going to have a hard time solving for t. So my suggestion would be is, if this is not conducive to solving for t easily, then solve the y for t and substitute it in for x. Especially because normally this would have more points down here, so this is not a function. So normally things that open up to the right that don't pass your vertical line test are going to be things that are x equals equations and not y equals. So we're going to solve this one for t. Oops. So my y minus 2 equals t. And that is going to get substituted in to this equation. It's a little bit easier and a little bit less messy to plug things in. Y minus 2 minus 1. So that's going to give us x equals y minus 3. Absolute value of y minus 3. So that way you know that it opens up right and left and it's not a function. Okay, now we're going to get into thetas. My suggestion for the thetas is to go use your standard ones from your unit circle. Your 0, your 90, your 180, and your 270. So for theta, I would always use 0, 90, 180, 270, and kind of do it that way. So that way, when I do x equals 3 times cosine at 0 is 1, cosine at 90 is 0, cosine at 180 is negative 1, cosine at 270 is 0, and cosine back, and then do 360. So we want to always go from 0 to 360 because I just want to be able to have a complete closed graph. And then you're back at 1. So that's going to give us 3, 0, negative 3, 0, 3. Then if I do my y, you're doing 5 times my sines. These are all my sines. 0, 5 times 1, 5 times 0, 5 times negative 1, back to 0. So that's going to give us 0, 5, 0, negative 5, 0. So we're going to go graph these on the next screen, indicating orientation. So our points were, let me move this down, make this bigger for a minute. Our points were 3, 0, 0, 5, negative 3, 0, 0, negative 5, back to 3, 0. So you can kind of see what graph you're getting, and that's my orientation. You're getting an ellipse in this case. So let's squeeze that back down, move this up. Actually, let me make this a little smaller. So if I want to eliminate the parameter, our two equations were x equals 3 cosine theta. Now you can probably do it from the graph, but you might get more complicated ones on your homework, so I would just make sure to do it with your trig knowledge. You need to remember that sine squared plus cosine squared equals 1. Remember I told you that you would never get away from that. So in this case, my x over 3 is what equals cosine, and my y over 5 equals my sine. So then I can substitute them in. This goes in for my cosine. This goes in for my sine. So now I have y over 5 squared plus x over 3 squared equals 1, which turns into y squared over 25 plus x squared over 9 equals 1, which is the equation of an ellipse. Okay. Example 6. If y equals x squared, so now we're going to go backwards. Instead of me giving you two parametrics, graphing it, and then getting to a rectangular, I'm giving you a rectangular, and I want you to go backwards and write two parametrics. And so I'm kind of giving you what the t value equals. So I want two equations that are y equals something with a t and x equals, oh, why am I writing the y first? Hold on. Let me go back and do this again. So let's do it. X equals something, a y equals something. Well, I already have an expression for t. So sometimes I'll have t equal to something with an x and something with a y, so it depends on which one I give you. So in this case, you just need to solve for x or y, whichever one I give you. Kind of like the other way, you solve for t and substituted it. Now you're solving for x. So that's going to be t minus 3 over 2 equals my x. So this is t minus 3 over 2. And actually, let me rewrite this better. Let's rewrite this so I have more space. So x equals t minus 3 over 2. And then my y, all I have to do is substitute this equation in here for x, and I'll be able to solve for y. So my y equals t minus 3 over 2 squared plus 2, which is t minus 3 squared over 4 plus 2, which is t squared minus 6t plus 9 over 4 plus 8 over 4, which ends up, if I combine all my like terms, t squared minus 6t plus 17 over 4. And there's my two parametric equations. Example 7, same thing. I need two equations. I need an x equals equation with a parameter, and I need a y equals. And over here, I'm going to solve t equals x plus 1 for x. So that just goes straight into here, t minus 1. Now I need to find my y equals, which means I need to substitute my t minus 1 into my equation and solve for y. So if I have t minus 1 goes in for the x equals 6 minus y squared. Move over my 6. T minus 7 equals negative y squared. Divide by negative 1. Gives me y squared equals negative t plus 7. And then I need to get rid of my square. So I'm going to square root it. Gives me y equals plus or minus negative t plus 7. And there are my two parametric equations. Projectile motion. For an object that's launched at an angle of theta, where the initial velocity is v(o), so it's like v subscript o. So you'll see the velocity here and here. The t has to stay in the equation. The gravity constant, these you need to make sure you know. It depends on the problem, whether or not you use 9.8 meters per second squared or 32 feet per second squared, depending on whether we give you meters or feet. And you might have to change them, like if we gave you yards or centimeters, inches, whatever. But these, you have to make sure that you know the gravity constant. And then the HO is the initial height. So if you kind of remember from your trig, everything basically is cosine comma sine. Right? Ooh. Cosine comma sine. So hence you've got your cosine here, your sine here. But keep in mind, when you're going horizontally, you're not going to have the effect of gravity. However, when you go up, you are going to have the effect of gravity pulling you down, and you also have whatever the initial height is that's going to have an influence. Whereas horizontally, you're not going to have the influence of gravity, just vertically. So my two equations are my t, which is my parameter, times the velocity times cosine theta, and for y, it's t times velocity sine theta. So if you didn't have the effects of gravity, you would just have these two. However, we have the effects of gravity, so we have minus 1/2 gt squared plus your original height. Example 8. Shane Leechler of Local Narrators has a record for the highest average punting record with a lifetime average of 46.47 yards. Supposed to kick the ball with a height of 3 feet and initial velocity of 28 yards per second at an angle of 72 degrees. So I want to write the two parametric equations. So here's what I have. I have, let me bring my pen. I have that my original height is 2 feet. I have that my velocity is 28 yards per second. My theta is 72 degrees. My g is 32 feet per second, since we're talking about feet. So the only thing I'm going to have to do is I need to convert this yards into feet. So there's 3 feet, 3 feet to 1 yard. So this is going to turn into 84 feet per second. So these are all of the things that I need for my equations. And I'm going to plug them in, and I'm going to get x equals t times my velocity times cosine of my angle, and then t times 84 sine of my angle minus 1/2 32t squared plus my original height. So if I put all that in the calculator, 84 times cosine of 72, make sure that your mode is on degree, is 25.96t. If I plug in 84 sine 72, I'm going to get 79.89t. Half of 36 is, half of, did I write 36? That's supposed to be a 2. That's a really bad 2. Half of 32 is 16, so minus 16t squared plus 2. I'll have to add another screen. If I want to know how far the ball traveled horizontally before hitting the ground, I'm going to have to figure out first how long it takes to hit the ground. So I'm going to have to basically find my x-intercept. 79.89t. Let's erase that. Minus 16t squared plus 2. And so we're going to have to use quadratic formula. So my y equals negative, this is my b, this is my a, this is my c. Keep in mind it's not in the right order. 79.89 plus or minus square root of b squared minus 4ac over 2a. And if you stick all that in the calculator, you're going to get 2. Okay, at this point I had to stop and re-record the video, so hopefully I didn't lose anything. After this point, when you stick it in the form on the calculator and get quadratic formula, you get negative 0.025 and 5.02 as solutions. The negative 0.05 doesn't count, and then if you plug x back in, 25.96 times 5.02, you get 130.32 feet, or if you divide that by 3, you get 43.4 yards.